Welcome to Smatter.
If you'd like to experiment along with me, grab some water and some dirt. This may get messy. Flooding is a serious issue. The water that backs up at my house is annoying, but nothing compared to the devastation that occurs from real floods. How do we combat flooding? This experiment is just a drop in the bucket, a smattering of knowledge. Use what you learned from this video to experiment and find ways that you can help to solve this enormous problem. Now let's take a look at the last time it rained at my house. The water backs up here every time it rains and threatens to flood my AC unit. We need to level it out, but maybe we could do something else, like change the dirt to see if it would absorb more water. I want to do an experiment. This is a scientific inquiry process. In this process, we start with making observations and asking questions. But we can't just ask any question. We need to ask a question that can be tested through experimentation and observations. What question do you think that we should ask? So my question today is, does the type of soil affect how much water is absorbed? Now, I've done some research, but I really want to test these soils myself. So today we're going to be testing different types of dirt, and we're going to see how much water it can really hold on to and absorb. The second part of the scientific inquiry process is to do research. I've included the links to my research in the description. Very quickly, though, clay soils seem to absorb the most water, while sandy soils absorb the least amount of water. Organic components such as leaves and stems seem to help with water absorption. With this information, I'm going to develop a hypothesis. A hypothesis is a possible answer to our question based on observations and research. I'm experimenting with the following: the yard dirt that you saw earlier, sand, potting mix, and topsoil. What's your hypothesis? Which one do you think will absorb the most water? My hypothesis is that the potting soil will absorb the most water because it has a lot of organic materials in it. I've created a data chart, and scientists often use data charts to organize their data that they collect. Notice that there are 3 trials here. I'm only recording trial number 1, but you'll need to go ahead and do at least 3 trials so that you can get an average and get enough information to make sure that your data is valid. Okay, we're back and we're going to set up our experiment now. The very first thing you need to do is to label each bag that you're going to be putting soil in. I have yard, sand, potting mix, topsoil, and a control. And then you're going to measure out the appropriate dirt to go into each bag. So I did a volume of 250 mils for those of you in the US. That's about a cupful. And then I have a control. And in the control here, you notice there's nothing. So a control shows what would happen if you didn't have an independent variable at all. And in this case, our independent variable is the dirt. So what should be in our control bag? If you said no dirt at all, at this point, you're correct. We're not going to put any dirt because that's our independent variable, the different types of dirt. But we are going to make sure they all have the same amount because we want to keep that constant. Now, We're going to add water. That's our next step. And we're going to filter it through a cup. If you didn't have a strainer, then you could poke some holes in the bottom of these bags and you could put that over the cup and do it. But I'm going to use a strainer this time. And so I'm going to put 100 mils of water into each bag so that we know exactly what is in there. Okay, now that I've added water to all the bags, I'm going to go ahead and put each of them into the strainer. As best I can. We're going to do that to the sand. And I can already see the sand has some water coming through it that hasn't been absorbed. Next, we're going to move over to the potting mix. This as carefully as I can. Whoa, so I'm looking at the camera instead of what I'm doing. We've got the topsoil. And finally, we're going to do our control. Okay, so it's been 5 minutes and I've got 3 different graduated cylinders here. One's 100 mils, one's 50 mils, one's 25 mils, and we're going to measure this water. I wanted you to look. This is the control after 5 minutes. And as you can see, hopefully, all the water we put in, we're going to get back out. Minus a couple of drops I spilled on the table. We are right back at 100 mils. So our control was exactly what we expected it to be. And we know from our control that nothing got stuck in the bag or in the strainer. Okay, so our next one is the topsoil. And it looks like there's a little bit less in here. Let's find out. There is 32 milliliters from the topsoil. And hopefully you're writing this down. We're going to organize our data in a few minutes. This one is the potting soil. And you know, I thought that the potting soil would absorb the most water. We're going to have to take these numbers, of course, and subtract them. So I'm going to put this down here. And we are going to measure the potting soil. And for the potting soil, we have 63 milliliters. It did not absorb as much water as I thought it would. Look at all that water it did not absorb. Now, it looks like the sand absorbed quite a bit. And we're going to take this, pour it in here. We don't want to get the sand. There's still sand that came through. And it is 12 milliliters. So most all of that, 88 milliliters, was absorbed. Now here's the surprise. I didn't think that my yard dirt would absorb that much water. And I want you to look here, because there is barely anything, I'll do it this way, in this container. I don't even think I can measure it with my 100 mils, so I'm going to go down to my 25 mil graduated cylinder and see if we can read anything off these few drops that are in here. Oof, it is less than 1 milliliter. Wow. Now, I had thought that my potting soil was going to absorb the most. I am incredibly wrong. So let's talk about that. The next step in the scientific inquiry process after doing the experiment is to record and analyze the results. After completing all 3 trials, I recorded the data, and then I took an average of each trial for each sample and recorded that as well. The next thing I did was to create a graph to represent that data. Notice that our yard dirt did in fact absorb the most water. And the big surprise was that the potting mix absorbed the least amount of water. So now we need to draw some conclusions. And when analyzing data, the scientists asked, does the data support my hypothesis? Well, my hypothesis was that the potting mix would absorb the most water. And in this case, the data does not support my hypothesis. So what are we going to do now? Well, I think that I need to go back and do some more research and see if I can find some clay and do this experiment again. In the scientific inquiry process, you can go back to any step at any time and start from there. The last thing we need to do is to share our results. In my case, I'm going to share the results with my husband and let him know that we don't need to change the dirt in the side yard at this time. Before we go, I want to share very quickly something about variables. The independent variable is the variable that we change on purpose, and it should be the only variable that you change. In our case, we changed the type of soil or the type of dirt. The dependent variable is a variable that we are measuring. In this case, we are measuring the amount of water that was absorbed. And then all the other variables, we want to keep them the same. They are called constants. Now it's your turn to create a new independent variable. Can you add something to the soil that will help it absorb even more water? You might try some paper or some shredded cotton balls. Add that to the soil. That'll be your new independent variable. Maybe you could add even some sand that we used in this experiment. Test it out and let me know what happens. Good luck. You're smart and you matter. You matter. Have a great day. Bye.